Hello, Geometry. This lesson is entitled Biconditionals and Definitions. Well, the first thing we need to know is what is a biconditional statement. A biconditional statement is the combination of a conditional statement and its converse. It contains the words if and only if. The thing about a biconditional is that the converse and the conditional, both of them must be true in order to create a biconditional. But notice again, it says it contains the words if and only if. So a conditional is an if-then statement. A converse is also an if-then statement, just where the hypothesis and conclusion are exchanged. But the words if and only if will appear in a biconditional statement. So here, it says, consider this true conditional statement. Write its converse. If the converse is also true, then we're going to combine the statement as a biconditional. So this first one says, if two angles have the same measure, then the angles are congruent. So the first thing it says it wants us to do is create the converse. So the converse would be this. If two angles are congruent, then the angles have the same measure. Again, notice we switch. Here's the hypothesis. Two angles have the same measure. And the conclusion was the angles are congruent. So on the converse, we flip those around. Two angles are congruent. Therefore, the angles have the same measure. And please understand, remember when you write the converse, you have to make it logically sound as well. So you might have to tweak the wordings a little bit. So on the conditional, it started off if two angles. We're talking about the two angles. So when we write the converse, we also say if the two angles. Say if two angles are congruent. Now, both of those statements are true. So therefore, when they are both true, we can create a biconditional. So the biconditional in this case would read just like this. Two angles are congruent if and only if they have the same measure. Okay, so since the conditional and converse are both true, we can create the biconditional. And notice that the if and only if appears in the middle of the sentence, not at the beginning, not at the end, but in the middle. Two angles are congruent if and only if they have the same measure. The thing about a biconditional is you can also write that in reverse as well. You can say two angles have the same measure if and only if they are congruent. So it actually doesn't matter if you want to start off with the hypothesis of the conditional or the converse. So again, make sure when you write the biconditional is that the if and only if goes in the middle of the sentence. Okay? Here it says, write two statements that form this biconditional about the whole number. So here we're given, we have to do this in reverse. We're given the biconditional. We have to create a conditional statement and its converse. Okay? So here it says, a number is divisible by 3 if and only if, again, keywords right there on a biconditional, if and only if the sum of the digits is divisible by 3. So first we're going to create a conditional statement from that, an if-then statement. So here's what the conditional would look like. If a number is divisible by 3, then the sum of its digits is divisible by 3. Again, since we're writing a conditional, we have the if-then statement. So we took the first half of the biconditional, that became our hypothesis. If a number is divisible by 3, the second part of the biconditional became our conclusion. Then the sum of its digits is divisible by 3. Now it says write two statements. So we have to write the conditional and the converse of that conditional. So here's what the converse would look like. If the sum of the digits of a number is divisible by 3, then the number is divisible by 3. Now again, we switch the hypothesis and conclusion. Now you may look at this and wonder why the converse is actually longer than the conditional for just switching the hypothesis and conclusion. But remember that we have to make sure our sentence makes sense. What are we actually talking about? If the sum of the digits of what? Well, if we just swap the hypothesis and conclusion, then it would read the sum of its digits is divisible by 3. Well, what is it? So when we write the converse, we have to clarify what it is, it being the number. So if the sum of the digits of a number is divisible by 3, then the number is divisible by 3. Okay? So again, make sure your wording makes sense and it explains what's going on when you write the converse from a conditional. Okay? But this is how we break up a biconditional into two separate statements. A conditional and its converse. And again, both must be true in order for the biconditional to work. Okay, let's move on. Notation and symbols. Now we learned with a conditional statement that we said if P, then Q. And the converse was if Q, then P. Well, since we said with a biconditional that both must be true, what we can do is have arrows going both ways, saying that it doesn't matter which way you start with, both will be true, conditional and converse. So the way you would read is P if and only if Q. So that's how we would read it. Not if and then, but P if and only if Q. And technically you can reverse that too. Q if and only if P. So either works. Okay, that's just talking about notation and symbols. So we want to make sure we are able to understand it when we see it. Now what's the definition? A definition is a statement that makes something definite, distinct, or clear, as by dictionary.com. Okay, so again, a definition, what makes a good definition? A good definition has a couple of different characteristics. One, it uses clearly understood terms, so we have to know what we're talking about here. Number two, it has to be precise, has to be exact of what we're actually talking about. Number three, it has to be reversible. When we reverse what it's saying, it has to also make sense. That is what a good definition is. So here it says, is the given statement a good definition? Well, the first one says an airplane is a vehicle that flies. Is an airplane a vehicle that flies? Absolutely. But the last thing I said was that a good definition is reversible. So is every vehicle that flies an airplane? No, not necessarily. So therefore, this technically is not a good definition of an airplane. Because, as we can see, a helicopter is a vehicle that flies. So we can come up with a different vehicle that flies that's not an airplane. So therefore, this in amongst itself is not a good definition of what an airplane is. It's true that it's a vehicle that flies, but again, it's not reversible in this case, so therefore it's not a good definition. A triangle has sharp corners. Okay, that's very true. It has 3 sharp corners. But again, when we reverse it, we have to ask ourselves, is everything with sharp corners a triangle? So, therefore, again, this would not be a good definition. So we come up with an example to show that it's not a good definition. So what we can come up with, just as one example, is a square has sharp corners. There's many unlimited things that have sharp corners. So we could say a rectangle, pentagon, hexagon, heptagon, octagon. So there's many different things that have sharp corners, not just a triangle. So again, a good, that's the key word there, a good definition has those 3 main components. It's clearly understood, has clearly understood terms, it's precise, but it's also reversible. Okay? Now let's move on. Oh, it looks like that's the end of our lesson. So here would be a good example of a good definition. A teenager is a person between the ages of 13 and 19. Okay, this is technically a good definition. First, clearly understood terms. It is precise, but also if we reverse it and we say a person between the ages of 13 and 19 is a teenager, that also is true. So this is a good definition for the word teenager. A teenager is a person between the ages of 13 and 19. Okay? So again, biconditionals, definitions, that's what this lesson's all about. I hope I made it a little easier to understand. Good luck.